Hello class, and welcome to another class with Professor Choi. Alright, so today we're going to be talking about the binomial probability distribution. So this is still part of my series on probabilities and statistics. Alright, so the binomial probability distribution is actually a very exciting distribution because you can go ahead and turn almost anything into a binomial question. A binomial probability distribution, or a binomial question, really is an event where you turn it into like a yes or no, an up or down, a right or left, or you could say something like early or late. So lots and lots of questions can be asked where you turn things into a yes or no, an up or down, or something like that. So a binomial probability distribution is where you have two possible outcomes, either a yes or a no, an up or a down, or on time or late. Events are mutually exclusive. Mutually exclusive basically means, by the way, that there is a line and you are either on the right of the event or the left of the event. So you cannot have like overlapping events. You cannot be like on time and late at the same time. You know, if I say early in my class or on time in my class is anybody who arrives before 8, then that's on time. And then after 8, then that's late. Alright? So I have to establish a line, and mutually exclusive means that events don't overlap. It's one or the other. Now it's the result of counts. So we're counting, you know, how many people are late or early, for example. And each trial is independent of each other. In other words, people don't arrive, in the case of my classes when I'm doing early or late, for example, is people are not arriving all together in a bus. So that means that the event of those people coming in late or early to my class is not really independent. So each trial is an independent trial by itself. Alright, so to calculate the probability for that, we use this formula. So probability of x is equal to NCX, and remember C stands for combination, which is something that I cover in a different video. Pi is the probability of the event occurring, whatever event you're measuring in this case. Then you have x, which is the question that they're asking you, 1 minus pi to the power of n minus x. Alright? And I left it here, so as we're doing the example, in case you don't remember what those mean, they are here. So C stands for combination, and combination is a formula, again, that I cover in a different chapter. Probably videos before this one if you're looking for them. And combination is also a function inside your calculator. So it's a sort of shortcut. And if you don't have it, by the way, then that's a formula in and of itself. So there'll be a formula for that as well that you have to use. Alright. N is the number of trials. X is the number of successes. Whatever you define as a success. Now the word success does not mean positive here. The word success is basically the one that you selected to measure. Like if I say how many people are late, then I'm defining late as a success. Or if I say how many people are on time, you know, what's the probability that somebody's on time, then I'm defining on time as success. Alright? And pi is the probability of the success trial happening. So we're going to use this example here to explain how to do binomial probability distributions today, and we're going to kind of run through multiple places on these examples just so that you understand how these can be used and then broaden, you know, beyond this. Alright, so let's say we have 10 buses running from the downtown station to the uptown station, and the probability that any of those buses is late is 0.1 or 0.1. What is the probability that none of them are late today? So what's the probability that 0 of them are late today? Okay? So the first thing you need to do is you need to kind of identify with the information that you have been given, where are you going to put it on the formula? Now if you're taking one of my classes, one of the things that I always like to tell my students is that for the purpose of exams, we kind of like to guide you. So, you know, because it's intro to statistics, you're going to notice that the problem is going to say something like using a binomial probability distribution, and that's just to like give you an idea of which distribution you have to use, because a lot of the times this is not obvious, especially for intro students. Now, whenever you become a statistician or whenever you have to solve these problems and you're not in a class, then the real key is to kind of figure out how to solve it. In other words, you're not going to get a problem that works very well like this. Instead, you're going to get more like a question. So your manager is going to come to you and say, hey, what's the probability that we're going to get more than 10 customers today? And then you have to figure out a way to solve that problem. And one of the ways in which you can solve some of those problems again is by turning something into a binomial question. A yes or a no, an up or a down. Okay? And then turning it into a statistical problem so you can go ahead and apply statistical techniques to answer the question. Alright? So anyway, let's kind of work on this problem. Say we have 10 buses running from downtown station to the uptown station. Probability that any of them is late is 0.1. Alright, so what I'm going to do is I'm going to take each one of those numbers and I'm going to assign it a letter. So we have 10 buses. The 10 is the total number of buses that we have running around. So this is going to be my n. The probability that any of them is late is 0.1. So notice that we have defined late as our success, and the probability of that is 0.1. So this is going to be my pi. And then the question is asking, what is the probability that none of them are late today? So this is the same thing as saying, I want you to calculate probability of x equals 0. Actually, let me put the x here so we don't miss that. Alright? So what's the probability that x equals 0 is really what they're asking me here. What are the probability that none of them are late today? Okay? Now that we basically use our letters, we can plug them into the formula. So we're going to do 10C 0, 10C 0, pi is 0.1, and in here, by the way, it's multiplication and multiplication. So we're going to multiply that. Okay? Actually, it will be useful probably to do this. Yes. And multiply times that. Alright, to the power of x. X is 0 in this case. Okay, then we're going to multiply that times this portion here, which is 1 minus 0.1, which is my pi. And then n minus x, n is 10, x is 0. So 10 minus 0. And there you go. We got our setup. Alright. I recommend solving it, each one of those. Alright, so don't try to like plug in all of that into your calculator, because you better be a bracket master if you want that to work. Okay? So, in any case, it's better to just solve it nice and slow. So we're going to do this portion here. Alright, now in case you haven't watched my other video, the combination is right here where it says PRB on my calculator, and I'm going to get this thing that says NPR or NCR. So we're going to be using NCR to solve our problem. Okay? So we're going to put 10 in the calculator, and then I'm going to click on PRB, and I'm going to select NCR, and then I'm going to put 0 because my n is 10, my r is 0, and c is what I want, and then I click on enter, and the answer is 1. So that's what goes there. Alright? Then I'm going to multiply that times 0.1 to the power of 0. That's going to be 1. And then I'm going to multiply that times 1 minus 0.1, which is 0.9. And then I'm going to put that to the power of 10. And what I get here is 0.3487. Alright? So the answer to probability x equals 0 is 0.3487. Alright, now let me write that down over here. So probability x equals 0 is 0.3487. Alright, so the answer to the question that they ask us, what's the probability that none of them are going to be late today, is 34%. Now remember that in statistics you got to be able to take 0.34 and turn it into a percent very quickly, because people would ask you questions in percent and you're normally answering questions in decimals. So again, 0.34 means 34%. Alright, now let's twist this question a little bit and let's keep working with it. Okay? So let's make one change. What is the probability that one of them is going to be late today? And that's the change that we're making. 1. Alright, now this question is asking you for only one bus being late. So exactly one bus being late. So it's the same thing as saying, what is the probability that x equals 1? Alright, so what's the probability that one bus is going to be late today? Alright, now let's set it up over here. So we got n equals 10, c, and then now it's going to be 1. Then we're going to multiply that times pi to the power of 1. So we got 0.1 power of 1. Then we're going to multiply that times 1 minus pi. 1 minus pi is still 0.1. And this one's to the power of 10 minus 1. Good so far? Alright, so we set it up. Now we're going to solve it little by little. We're going to do 10 combination 1. So here we go. We're going to put 10, PRB, select NCR, put 1, press enter. The answer is 10. Okay, so this is 10. 0.1 to the power of 1. That's 0.1. Then we're going to do 1 minus 0.1, which is 0.9. And that is to the power of 9. That's 0.3874. Alright, once we solve each one of these, we got to multiply them all, and that's the answer. Okay. So this is equal to 0.3874. So probability x equals 1 is 0.3874. Alright, hope you've been following me so far. If you haven't, let's do it again. Alright, so let's change it. Let's say the question now says, what is the probability that 2 of those buses are going to be late? Alright, again, this question is asking you for what is the probability that exactly 2 buses are going to be late? Exactly 2. That's what that is. Okay, so not 3, not 4, not 5, not 1. Exactly 2 buses are going to be late. Okay, so it's basically asking probability of x equals 2. Alright, so we got to plug it in. N is 10. So we're going to do 10 combination 2. Multiply that times pi to the x, 0.1 power of 2. Then multiply that times 1 minus pi and 10 minus 2. Okay, once we set it up, we solve it little by little. So we got to do 10 combination 2. Alright, put 10, PRB, combination 2. Enter. I got 45. Then we're going to do times 0.1 squared. And then we got to multiply times 1 minus 0.1, which is 0.9, to the power of 10 minus 2, which is 8. Alright, once we solve each one of those, put it all together. Okay, and I got 0.1937. That's the probability at x equals exactly 2. Alright, I'm going to write it here. Probability that x equals 2 is 0.1937. Hey, I hope you're having fun. I am. Okay, so as you can see, you can calculate the probability of any individual amount of buses being late. So in other words, no buses are late, 1 bus is late, 2 buses are late, 3 buses are late, 4 buses are late, each one of those probabilities. Now another cool thing you could do with this is you can calculate the probability of more than one event happening. So imagine now that I ask you a different question. Alright, so what is the probability that 2 or less buses will be late? Okay, so what is the probability that 2 or less buses will be late today? Now, this question here is different than what we've been asking before, because now we're not just asking you exactly 2 buses, but we're also asking you for 2 and anything less than 2. So that's actually probability of 2 buses, 1 bus, and 0. Okay? So this is the same thing as saying, what is the probability that x is less than or equal to 2? And the answer to what's the probability of x less than or equal to 2 is probability of 2 plus probability of 1 plus probability of 0. So it's 2 and anything less than 2. Now, if we didn't have a shortcut like tables that I'm going to show you in a bit how to use, then what you would have to do is you would have to calculate the probability of each one of those, like we did here. So you got to calculate probability of 2, probability of 1, and probability of 0, and then you add it. Okay? So the answer to this question, since we already calculated those probabilities, it's equal to 0.1937 plus 0.3874 plus 0.3487. And that is our answer for what is the probability of x less than or equal to 2. Alright, and the answer is 0.9298. That's the probability x less than or equal to 2. Alright, let's do another one. Let's change it a little bit. Imagine that I ask you, what is the probability that less than 2 are late? Alright, I know it might sound fairly similar, but it's not exactly the same. Because when I say 2 or less, I'm including 2. When I say less than 2, I'm not including 2. So basically, the answer to this question is probability of x less than 2. And less than 2 does not include probability of 2. So we need to get rid of probability of 2 in order to answer less than 2. So if we're being asked less than 2 buses are late, then we're going to go probability of x less than 2, and we're going to go probability of 1 and probability of 0. So we're not including 2. We do 1 and 0. We already have probability of 1 and we have probability of 0. So let's add those. Okay, and the answer is 0.7361. So probability of x less than 2 is 0.7361. Alright, if you're taking one of my classes, I've given you one of these and you should be using it. If you're not taking one of my classes, you can find this online. Plus, this is available in Excel. So if you have Microsoft Excel, you can use that to calculate these probabilities. In my classes, I distribute one of these because these are tables that are readily available for you to be able to calculate these questions in a fairly easy way. So I'm going to transform this into something that we haven't done right now, and we're going to use that table to solve it. Okay? So we're going to keep that the same. And now I'm going to ask you, what's the probability that 6 buses are going to be late? Okay? So what you want to do is you want to go into the tables that I gave you, and you want to look for the table that says binomial probability distribution. Then at the top of the table, so you need to look for the table that says binomial probability distribution. At the top of the table, you're going to get your n. In this case, we need to look for n equals 10. Okay? Then on the part of the top of the table, you're going to find your probability. And the probabilities in this case start at like 0.05, it goes to 0.10, 0.20, etc. And then on the side, you're going to find your x's. Okay? So you got to find the table that says binomial probability, and then n equals 10. Alright? Then you got to find the one that says pi equals 0.10. So the one that has probability 0.10. So n equals 10, probability 0.10. And then you're going to notice that if I ask you the question that we did, what is the probability that 0 are going to be late? The answer is right there and it's the same. Probability that 1 is going to be late, the answer is there and it's the same. Probability that 2 are going to be late, the answer is there and it's the same. Okay? So it will be on 0, 1, 2, you'll find it there. Alright, so the way for you to find what is the probability that 6 buses are going to be late is the same thing as saying Px equals 6. So what I'm going to do is I'm going to take the x, go all the way down to 6, and then I'm going to read across at point 1, And the answer is 0. 0.000. Okay? So probability that x equals 6 is 0.000. Alright, notice that with this table I can ask you any question I want. I could ask you what's the probability of less than, more than, equal to, higher than, or number and higher, okay? So I could ask you anything. If I say, what's the probability, let's change this again. Let's say that we do 4 or more buses. Okay? So what is the probability that 4 or more will be late? Okay? Now, probability of 4 or more will be late is the same thing as saying probability of x greater than or equal to 4. Because I'm saying 4 or more. That includes 4. So a probability of 4 or more is the same thing as saying probability of 4 plus probability of 5 plus probability of 6 all the way down to probability of 10 because we have 10 buses. Okay? So the answer in this case, you would have to go n equals 10, look for 0.1, then look for 4, and then add 4, 5, 6, 7, 8, 9, 10. Now, in the table, I got probability of 4 being 0.011. Probability of 5 is 0.001. So therefore, the probability of more than 4 is equal to 0.012. So probability of more than 4 is going all the way down to 4 on the table and adding it all the way down to 10. So 4 through 10 on the table. Alright. I hope that was a useful lesson on binomial probability distributions. Again, the most important thing about binomial probability distributions is that you can turn almost any question into a binomial question. Just kind of ask, you basically have to ask the question differently. Okay? And there you are. Binomial probability distributions. Remember, one of the coolest things about videos is that you can actually just go back and rewind if you missed any of the steps. And I think I did all the steps fairly well. So, you know, you can kind of go back. So, in any case, thank you for tuning in to Professor Choi, and stick around for more knowledge of statistics, economics, finance, and even daily life for people. Please subscribe to the channel if you think some of this stuff is useful to you. It will be a great service to me. Thank you very much.